I'm continuing to study the erosion yield of polymers on different MISSE missions, and as one example, this is a picture in the upper right of the stress piece polymers experiment that was flown as part of MISSE 6, deployed in March 2008 and retrieved in September of 2009 after about a year and a half of space exposure. And this picture shows the non-stressed sample tray on the left before flight, and on the right after flight. You can see a lot of color change. And so I have characterized the erosion yield of these non-stress samples. I still need to characterize the stress samples yet, and that's one of the things I'll be working on soon. But having erosion yield values from various MISSE missions provides very important information on erosion versus mission duration. For example, this chart shows two different polymer materials that were flown on various MISSE missions, and when we look at the erosion yield versus atomic oxygen, we can see for these particular polymers, the erosion yield appears to decrease with atomic oxygen fluence, and that's information we would not have known if we'd only flown the samples once in space. So real quickly, I'd like to tell you about our collaboration with students on these experiments. The students are from Hathaway Brown School for Girls, and they work primarily on these peace experiments, so we call ourselves the peace team. And we have 3 to 6 girls come out and work with us throughout the school year. They come out Friday afternoon for a couple hours, and they work full-time during the summer at NASA. And the research includes anything that I think they're capable of doing, including pre-flight characterization, flight sample preparation, post-flight characterization. And there's been a lot of benefits to both NASA and particularly, of course, the students. For example, most of these students are graduating with technical publications and presentation experience as high school students. My favorite story is when we had 2 of our students present an oral presentation at a space conference in Toronto as high school sophomores. And the girls also have entered their MISSE-related research in national and international science fairs and have won over $80,000 in scholarships and awards. So I'd like to really quickly introduce just a few of the many other MISSE experiments that have flown, because I'm just one of many, many investigators flying samples. There have been thousands of samples and hundreds of devices flown on MISSE. The Naval Research Laboratory is using MISSE as a test bed for active solar cell experiments. And they call their experiments the Forward Technology Solar Cell Experiment, or FTSE. The first FTSE, FTSE 1, flew on MISSE 5. MISSE 5 is the only mission where just one of these packs or trays flew, and it was placed in a zenith nadir orientation on orbit. It was launched in July 2005 and retrieved about 13 months later. And so the experiment goal for FTSE is to rapidly put current and future generation space solar cells on orbit and provide validation data for these technologies. MISSE 5 did provide rapid access to space for DoD, and it produced mission-critical solar cell performance data, providing anomaly resolution data for on-orbit spacecraft, real-time data that enabled DoD mission hardware to be designed and built, and on-orbit data that was used for ground test data validation. NRL has a FTSE 2, which is currently being flown as part of MISSE 7, and as part of FTSE 2, they have 36 different solar cells that they're measuring the IV curves, and the data is being telemetry down through space station. Shane, and I'd like to mention that the points of contact for the FTSE experiments are, Rob Walters and Phil Jenkins at NRL. Shane Jewell very kindly put together this slide to let us know a little bit about the Air Force Research Lab's MISSE experiments. And Shane says that the Air Force Research Lab has contributed well over $15 million to the MISSE program and has seen immeasurable benefits from new higher-powered solar cell technology, electromagnetic shielding, nanomaterials, to fundamental science and a better understanding of atomic oxygen erosion. MISSE has been a testing and proving ground for the Air Force Research Lab. Currently, AFRL has 10 experiments, 6 of which are active, up on MISSE 7 with 130 samples. And the types of technologies that they're looking at are listed in the blue box. But Shane says that the benefits to them include material validation, processing recertification, model verification, and a better basic science understanding. The next 2 slides provide International Space Station vehicle materials information that were flown on MISSE. And the intent of MISSE participation by the Space Station Vehicle Office Materials and Processes team was to fly witness materials of key external space station materials as a means to monitor space environmental effects such as thermo-optical property changes, mechanical property changes, and also contamination effects. And they have flown space station-related materials on all the MISSE missions except for MISSE 5 and the upcoming Mission 8. The results from the space station materials flown on MISSE have shown verification of the stability of the vast majority of their thermo-optical surfaces. They've shown verification of the effect of space station control via material selection. So by using the right material selection, you're able to prevent molecular contamination on orbit. They also found from MISSE that if you seal an anodized surface using nickel acetate, it will rapidly darken due to UV radiation, which was something that was not determined from the ground testing. And so they conclude that if you're going to do an anodized processing for space exposure, unless you're going to further dye the material, you should specify deionized water as a sealing technique. Boeing and Space Systems Loral have teamed up and flown multiple passive radiation detectors, and these are thermoluminescence detectors, or TLDs, and they were flown on all the MISSE missions except for MISSE 5. They take the individual detectors and they shield them with different materials and or thicknesses, and then Boeing has measured the output of the TLDs post-flight. And this chart shows the results from those MISSE experiments where they have plotted their data of dose versus shielding thickness. And a couple things is that they found their data is good correlation with some data from a Russian experiment called Bion 11, I believe is how it's pronounced. But the other thing that was important that they found was that their MISSE data, which was in space for 4 years, was in good correlation with space station calculated doses for only 1 year, and hence they conclude that space station actually provided very effective radiation shielding to the MISSE experiments. And the PIs for these experiments are here in the audience, Gary Pippin, Jerry Wirt from Boeing. So if you are interested in learning more about these radiation experiments, we can have you talk to them.